For the last century, the most expensive commodity on Earth wasn't oil, gold, or land. It was human cognition. If you needed messy code organized, legal files summarized, or support tickets sorted, you had to pay for a human brain to spend hours doing it. It was the most binding constraint on human progress. But in the last 24 months, the price of that thought has been put into question. We are living through the first ever industrialization of cognition, and it's rewriting the basic laws of business as we speak. Today, we're investigating the new economics of AI, where basic expertise is becoming a commodity. Think about the last time you told a story to a friend. When you started that first sentence, did you know exactly how it was going to end? Usually, the answer is no. You have a vibe, a goal, an intent, but the specific words, they just appear. You trust your brain to find the next word, and the one after that in real time. You are building the bridge as you walk across it. This is how the most advanced AI on Earth works. It's a next token predictor, a glorified autocomplete. It doesn't know the end of the paragraph when it starts the first word. It is simply calculating the most statistically likely bridge to the next point. We used to think this flow, this ability to generate coherent thought on the fly, was the spark of the human soul. But it might just be a very sophisticated form of pattern matching. Look at this example, where we confront the AI with the following statement. There are more hydrogen atoms in a single molecule of water than there are stars in the solar system. To see this next token logic in action, look at how a high-speed model like Gemini 2.5 Flash handles this trick question. It gets it confidently wrong. Why? Because based on its training data, the statistically most probable answer to any question about the scale of the solar system is that people underestimate its size. The model is simply following the most common pattern in human error. But then, something fascinating happens. As the model generates more tokens, as it speaks its reasoning, these words are added back into its context window. The AI is effectively reading its own thoughts. Just like a human who realizes they're wrong halfway through a sentence, the model starts to meander. It sees its own math, realizes the statement was actually true, and tries to pivot its way out of the mistake. You can think of token generation as a form of computation. By letting a model reason through a problem, you are expending more tokens to process more information. It's the AI version of think before you speak. The more tokens you allow a model to burn, the more refined the answer generally becomes. Newer models like Gemini 3 Flash actually get this right immediately. Even the fast and cheap models now have minimal thinking integrated to not fall for trick questions that seem false at first glance. To understand the limit of AI, you have to understand the difference between interpolation and extrapolation. Most of what we call work is actually interpolation. It's taking two known points, like a customer's problem and a company's policy, and finding the path between them. It's taking a billion lines of existing code and predicting what the next line should look like, based on what has been done before. AI is a master of the known universe. It can interpolate between every book ever written, every song ever composed, and every movie ever produced, to give you something that feels new, but is actually just a sophisticated average of what has been done before. But AI struggles to extrapolate. It cannot easily step outside of its training data to discover fundamentally new laws of physics, or invent a genre of art that doesn't have a precursor. It can't boldly go where no data has gone before. This is the 0 to 1 problem. AI is incredible at going from 1 to n, taking an existing idea and scaling it, optimizing it, and repeating it a million times for free. But the jump from 0 to 1, the true act of discovery, still requires a human. This is why AI books, music, and videos can feel so bland and generic, because you have read, heard, or seen it in another form before. Mimicking human intelligence has become easy, But reaching true superintelligence is a different beast entirely, one that will likely require a fundamentally new approach and architecture. Despite these limitations, the economic implications are profound. It means that everything that has been done before can theoretically be automated. If your value to a company is knowing how things are done, you are in the path of the storm. But if your value is extending the frontier, finding the things the data hasn't seen yet, your value has never been higher. In the AI economy, we are moving from an age of expertise to an age of exploration. For the last few years, AI agents were more of a promise than a product. Early experiments could browse the web or write basic scripts, but they were fragile. They required constant human intervention to stay on track. In a professional context, they were a novelty, not yet a reliable foundation for business. That changed with the release of models like Claude Opus 4.6. This represented what many call the reasoning threshold. For the first time, the model's internal logic became robust enough to handle edge cases, the unexpected errors and subtle nuances that previously broke agentic workflows. Tools like OpenClaw have given us a window in what this looks like in practice. It's an orchestration framework that treats the model as a CPU for language, allowing it to take direct action, navigating file systems, managing browsers, and interacting with APIs autonomously. We are seeing the first real-world use cases emerge. Imagine an agent that doesn't just write a marketing strategy, but actually browses dozens of competitor sites, synthesizes the data, drafts the ads, and sets up the entire Shopify store in a single session. Or a developer agent that doesn't just suggest code, but enters your GitHub, fixes the bugs, and deploys the update while you sleep. To be clear, in their current state, these tools are unrefined. Utilizing a framework like OpenClaw is a precarious undertaking. The systems are prone to failure, and granting a generative model direct access to a local file system remains a significant security liability. We are effectively in the homebrew era of AI, a period defined by independent developers iterating in isolation. The structural shift occurs when industry leaders like Anthropic, OpenAI, and Google commit their vast engineering resources to productizing and hardening these frameworks. Once these early-stage instabilities are resolved and enterprise-level security is integrated into the architecture, the implications will be profound. We are moving beyond the era of using a tool and entering an era of delegating to a system. The path to cost efficiency lies in hierarchical AI agents. Running a state-of-the-art model like Opus 4.6 for every single minor task is prohibitively expensive. Instead, the autonomous organization uses a tiered system. The master agent, the expensive, high-reasoning state-of-the-art model, acts as the supervisor. It understands the goal and creates the plan. It then delegates the individual steps to a fleet of sub-agents, smaller specialized models that are significantly cheaper and faster. By using the expensive brain only for the orchestration and the cheap muscle for execution, the cost of complex operations drops significantly. But lowering the cost is only half the battle. To achieve broader automation, you have to remove the human bottleneck. This is where the self-correction loop comes in. As long as you have a master AI that can judge work as a human would, you can create a self-improving system. The master model audits the sub-agent's work, catches errors, and forces iterations until the output meets the required standard. Because the AI can now act as its own quality assurance department, you effectively have a workforce that never sleeps. While you are away from your desk, the agents continue to iterate, test, and refine. They operate on a persistent heartbeat cycle, executing shell commands and browsing the web 24/7 without fatigue. This combination, hierarchical cost-saving and self-correcting autonomy, is what makes the one-person company a viable, scalable reality. We are all becoming managers of a digital workforce that doesn't just follow instructions, but proactively completes the mission while we sleep. We are of course still in the early stages, and the tools are just now becoming robust enough for professional use. But the trajectory is clear. The competitive advantage of the future won't belong to the person who can do the most, but to the person who can best guide and manage the agents that do the doing. Within knowledge work, we are all becoming managers. In economics, value is a function of scarcity. We pay a premium for things that are difficult to do, find, or know. For decades, tech giants built moats around their proprietary knowledge and their ability to produce code at scale. Today, some of those moats are shrinking. When a startup can use an agentic workflow to recreate a billion-dollar company's software stack in a single weekend, the incumbent's advantage is materially eroded. We see this most clearly in the labor market. We are entering an era where we may require more software engineers but far fewer software developers. A developer focuses on syntax, the manual act of writing code, but a software engineer focuses on the system, the architecture, the security, and the integration of moving parts. As AI takes over the writing, the human's value shifts entirely to the engineering. This doesn't mean knowledge work is dead. It means it is being redefined. Historically, when technology makes a task easier, we don't just stop working. We shift our priorities. Most jobs won't be fully replaced, but the boring 80%, the data entry, the initial drafting, the basic research is being automated. We aren't being replaced. We are being promoted to the managers of our own roles. However, unlike the Industrial Revolution, this shift is happening at a velocity that makes retraining incredibly difficult. Behind the scenes, the physical economy of AI is undergoing a tectonic shift. For the past few years, the story was about the cost of training, the billions spent to birth the brain. But in the long term, inference, the cost of actually running the model, will dominate. As agents like OpenClaw begin to run 24/7, performing millions of microtasks per second, the demand for inference compute is skyrocketing. The economic center of gravity is moving from the birth of the AI to its life. Recently, the market punished big tech, specifically Google, for their massive increases in capex plans. In our humble opinion, and to be clear, this is not financial advice, the market may have gotten this wrong. These spending plans aren't speculative. They are demand-driven by a structural shift toward autonomous agentic workloads. We believe we are still in the absolute infancy of this cycle, and the world is nowhere near having enough chip fabrication capacity to meet the coming inference explosion. Google's investment in its inference chips, like the TPU, is becoming increasingly valuable. While the world scrambles for general-purpose GPUs, we believe that those who own the custom silicon designed specifically for inference will hold a strategic advantage. In an economy of autonomous agents that never sleep, efficiency is king. The ultimate winner isn't necessarily the provider of the smartest model, but the one that delivers the highest intelligence at the lowest cost. The surging demand from agentic inference means chip shortages are likely a structural reality of the next decade. To understand why, we have to examine the brutal economics of silicon fabrication. A modern leading-edge fab costs upwards of $20 billion each and have lead times measured in half decades. You cannot simply spin up more capacity when demand spikes. You have to commit to a 5-year construction project and hope the market is still there when you finish. This timeline is further throttled by the extreme scarcity of the machinery inside. The most advanced nodes require UV lithography machines from ASML, systems so complex and difficult to produce that their limited availability creates a bottleneck within a bottleneck. Building a fab isn't just a matter of capital. It's a global waiting list for the only machines capable of printing the most advanced chips. Historically, the semiconductor industry has been defined by boom and bust cycles. Periods of high prices lead to massive overexpansion, which inevitably leads to a glut, where the market is flooded with chips. Prices collapse and manufacturers lose billions. These historical precedents made companies like TSMC, Samsung, and Intel extremely reluctant to increase capacity rapidly. They are haunted by the fear of overcapacity, even as the AI era demands an almost infinite supply of computing power. The chip shortage is so acute that high-profile customers like Tesla and SpaceX are desperate for dedicated silicon to power their autonomous cars, humanoid robots, and orbital data centers. Out of necessity, they are moving to build their own chip fabrication facility, despite having absolutely no prior experience in the field. Going into this research, we believe the massive surge in semiconductor valuations was highly speculative, perhaps even overblown. But after accounting for the scale of the looming inference explosion, our perspective has shifted. The market might still be underestimating the sheer volume of silicon required for the coming agentic future. It's easy to look at this inference explosion and feel a sense of dread. But volatility is just another word for opportunity. Right now, we are in a unique window. Intelligence is being heavily subsidized by the world's leading AI labs, as they burn billions to capture market share. This is the time to experiment, while the thinking power is being offered for free. Few things are as hollow as completing a grueling manual task, only to realize an AI could have executed it with superior precision in seconds. But the true danger is the invisible waste. The hours of human life lost simply because we failed to realize a better way already exists. If you are a high school student today, you are an AI native. You are growing up with the tools and their logic. Just as the previous generation gained an insurmountable lead by mastering the PC and the internet, you have a natural advantage. You don't have to unlearn the old way of working. We are moving from an era of doing to an era of directing. The process is being automated, but the purpose remains entirely yours. Don't be discouraged by the speed of the machine. Learn to be its architect. Because in the inference era, the most powerful tool isn't the AI, it's the human with the vision to lead it. Thanks for watching. Subscribe to stay ahead of the curve, as these technologies redefine our future.